And so really that, I just want to talk about why. So like, this was, I don't even think I really have a great document on our GitHub yet, on our docs. Like, why Webpack? What is it solving? And to really understand that, you kind of need to know the origins of like how we've used JavaScript on the web, right? So, I mean, how do you use JavaScript in the browser? There's really only two ways. That's it. There's only two ways that you can use JavaScript and load it in the browser. And I mean, JavaScript is just a script. It's just top-down, bottom execution. And as you can see here, like this is JavaScript. It's just a script format. It always has been up until late. And like I said, there's only two ways that you can actually get this functionality to work in the browser. The first way is adding a script tag and passing a source attribute and a reference to that JavaScript file. And this is great. This is how we leverage when we're using Webpack today. And then the second way is to actually just write your JavaScript in your HTML. JS in HTML, it's that new thing. Have you heard of it? No. It's been around forever, but you could do this. But I mean, when you break it down, so those are the only two ways, but what are the problems with these things? It doesn't scale whatsoever. I mean, you're either going to have too many scripts that you're trying to load from, script tags in the HTML. And each browser actually has bottlenecks. This creates a bottleneck. There's only a certain amount of concurrent requests that can fetch data, at a single time. And so, breaking your application into, 100 JavaScript files and loading them in the browser is a huge performance problem. And some people might say, but Sean, HTTP2 will help. And not really. Even if you had, let's say, 2,000, what the concurrent requests, usually they say 30 to 50, but your application has thousands and thousands of modules. We're talking 3,000. Companies like Airbnb and Microsoft's Outlook web app, they're talking 30,000 modules to build their application. And so it's just a wild, there is no way that you can have a performant experience by trying to load individual scripts. I could beat that horse dead for days. But then, so you're like, well, Sean, I'll just write one big one, right? 10,000, who's worked on the 10,000 line global.js file that ships on every page? Yeah. So I worked for an e-commerce company called Hayneedle, and that was my first experience with JavaScript. It was a single 10,000 plus line file called global.js. And of course, these are all the things that I struggle with, endless, I remember spending nights trying to debug, why one function wasn't working, to only find out it was because I was knocking out another variable that was at line 10 while I was working in line, 9,000. One of the quirks of JavaScript that I think irks people coming from different language ecosystems is that we have this crazy idea for scoping. Everything is global in its scope. But you can also have things like first-class functions. And so everything is global. Your functions, your objects. And so there's a lot of issues with just scope and variable conflicts. But this, we solve things in the web ecosystem. So what do we do? Who knows what an IFI is? IFI? Cool. That's a good start. So an IFI stands for immediately invoked function expression. And what does this mean? So take this code example here. Now, essentially what's happening is that we have this, we'll have a function that's defined, but it's wrapped in parentheses. And then you'll see at the end, it's called. And so what this does is that when you have an IFI, it's treated as an expression and instantly executed. But it also allows us to provide data from an outside scope and then return scoped information. So in this case, if you were to write this code in your Node terminal or whatever in DevTools, you're going to see that whatever actually returns properties on some, just like if it was a module or some sort of object. And that was the kind of goal here, right? Like we want to be able to way to encapsulate. And that's what ifs do. So if you took this and you removed the iffy pieces, you would notice that if you like ran this code, you had a variable declared at the top, so outer scope is equal to 1. And let's just pretend the iffy's not there. Well, then you would define var outer scope inside of the function, which gives it its own function scope, but then that actually knocks out the value in the outer scope. So if I ran console.log outer scope, I would find out that it returns 1. So instantly you can see why ifs solve big problems. Like now we can have the inner scope of that variable with the same name as the outer scope. And it's all about having encapsulation. So people started to instead ship their JavaScript but have individual files that were wrapped in ifs, right? And so then that way they could do things, and this is not the only module pattern. Like the revealing module pattern is just one of like a bajillion if you've ever read the JavaScript design patterns. And there's me and Addy hanging out. He's a good friend of mine. And he's the author of this book, but you'll notice that most of them are just surrounded by the idea of using encapsulation primitives of immediately invoked function expressions. But this lets us concatenate. Now we can take and write 100 files, and we could squish them together without concerns that we're going to knock out a bunch of variables and scopes. Like, and I put a star there because there's always caveats. But however, and this really led to the explosion of like these toolings. So we started seeing tools like make. Who's used make on a JavaScript project? Like, I did that for the first time. So in Microsoft Edge, Edge is part of the operating system, and so our OS code base is a 24 terabyte Git repo, and it uses nmake, which is like our custom Windows version. But I had that first experience of trying to use make with JavaScript. Boy, it was frustrating, really frustrating. But some people love it, and really all the purpose is just to concatenate the files together. And that's what grunt and gulp and broccoli and like all of these things. That's where these tools started cropping up, trying to solve problems. However, there's still problems with this. What is you're going to notice that anytime you want to change one file, you have to rebuild the whole thing. We're just concatenating all of these modules, or not modules, but these scripts together. And then more importantly, like when you concat, let's say, who uses Lodash here or Moment.js, like, all right, that's a huge library. That's like 1 meg, 2 megs of JavaScript, maybe even 3, I can't remember. JD will tell me when I get back to work. But if you're just concatenating files together, how do you remove code that you're actually not using? How do you even know there's code you're not using? When you're in scripts, there is no way. You're essentially, if you're only using one function from Lodash or one date utility from Moment.js, you're literally adding the entire library and just squishing it together. And it turns out that immediately invoked function expressions are kind of slow. So what happened? Nolan Lawson, who's one of my coworkers, an author of CouchDB, or PouchDB, I can't remember. He did a study and found out that bundlers, this was specific to bundlers early on, were creating lots of ifs and using a similar pattern. Or like people were writing in ifs and concatenating together. But what this does is it forces JavaScript engines to eager parse the code. And so you incur much more, how would I say, intensive or costly parsing time when your JavaScript's loading, so which leads to slower loading apps. And how do you lazy load with a task runner? You don't. There is no way. Like whatever you're building, you're shipping the whole, like you're shipping all that code down the pipeline. Even if your app maybe only uses 10% of it to load and get your initial experience, right? So you can just kind of see there's a lot of problems here with just shoving scripts together.